Welcome to Beyond the Microchip, brought to you by Microchip Technology. In part one of our two-part episode on microchip technology powers sustainability, we discussed sustainability trends in power delivery and modern building techniques that try to leverage those technologies. In part two, we continue our conversation and get into the products and technology that drive this phenomenon. Thanks for listening. Let's go beyond the microchip and hear a story of empowering innovation to enhance the human experience. That is a good bridge to our next topic, as we were actually going to get into some of the products that we're talking about here. I mentioned the PD77728 and PD70228 in the intro, but those have really, really low power consumption, right?
Yeah, one of the things that we attempt to do in our design is make it as power efficient as possible. But another unique feature about our design of our ICs, and we have three types of ICs. So specifically, we're talking here about a power source equipment IC. This is a controller and a manager. And these are the ICs that go into switches, they go into routers, they go into gateways, things like that, that will put power on an Ethernet cable. Well, we attempt to get as much functionality in our IC itself, as many devices in our IC itself, so that you don't have to surround our IC with anything. This will create a smaller footprint. It's when deploying total cost of ownership, a total BOM is going to be much less when you're designing it. So we put a lot of it, and the only thing you need for it is a cap on our IC, a resistor cap, and you can deploy it. So we take up very small space on the board, yet despite the fact that we are packing a ton of circuits into our ICs, we make it highly, highly energy efficient. And we just announced our 7th generation of our power source equipment ICs, what we call our 777 or the PD77728. This is an IC that has extremely low power consumption. By having low power consumption in its functionality, it delivers much higher power to the ports. Or if you could power 10 ports if you can power 4 ports off of one, this will give you the ability to power 5 ports because we're not using as much. The other thing is we make these ICs called power device ICs, where you put in your devices like an IP camera or an IP phone. That will take it off the line, but to deploy into an IP camera, IP phone, before that you need a diode bridge. And we make a diode bridge not out of diodes, but out of FETs. And what we do with that is it's, again, very small footprint, but it consumes significantly less power, which leaves more power available for the device itself. So if you were building a device and you could use class 6 power with a traditional diode, you might be able to use class 5 PoE power with one of our ideal diode bridges.
So a slight modification of the design, you can use lower power.
That's exactly it. So we've been putting these energy efficient considerations into not only the design of our ICs, but we're kind of unique in the power over Ethernet business. In 1998, when we introduced the first IC to put power onto an Ethernet cable, there were no IP switches. So in 1999, we invented the first midspan, also known in the industry as an injector. So we took one of our PSE chips, we put a power supply on it, and then we had the Ethernet cable coming out of the switch go into our midspan, and then another cable coming out of our midspan, and that would inject power onto the cable. So what happens is this power over Ethernet is a highly energy efficient technology. Again, all technologies have some energy inefficiency, but this has got a lot of energy efficiency in because the power never turns on until a device requests it. And then what happens is that PSE chip classifies how much power is requested, There are 8 power levels, all the way down from 4 watts all the way up to 90 watts at the source. And it delivers the class of power that is requested. So it's only delivering the amount of power that is requested. However, there are standards. There are energy efficiency standards all throughout the world. In the United States, they're known as Energy Star.
Energy Star
program. It's from the Department of Energy. Way back when we started this, the standards were much lower. The thing that applies to us is how much energy can be consumed. We talked about this last time, vampire energy.
Vampire power, that's right.
How much energy can be consumed when it's not delivering power, so it's monitoring. And over the years, that level got lower and lower and lower. Well, we still make mid-spans today. We still make injectors today. We sell them to people who install wireless access points, cameras, things like that. We also make them for manufacturers who make these devices so that when they offer a IP camera, they can offer also a powering module for that IP camera. And right now, the energy standard level is up to Energy Star 6 or DOE 6. They're about to ratify 7. And we have just reintroduced a new line of our midspans that also meet Energy Star 6 or Energy Star 7 criteria for when it's in a no-load situation, it is consuming the least amount of power possible.
Do you think we'll be ready for Energy Star 7?
We are ready for Energy Star 7.
Oh, okay.
Just this month, we announced a 15.4, a 30, and a 60-watt unit. In April is coming an 80-watt unit. These are all our indoor units, and we're already testing some of our higher data rate units. So all the units that I mentioned were 1 gigabit per second, but we build midspans that support up to 10 gigabits per second. They're coming out in April, May, and June, and then we're also in the midst of redesigning our outdoor units too, to all be Energy Star 7 compliant.
One of the features we have here is that we have e-waste reduction, 100% recyclable packaging. Is that why PVC free is such a good thing?
It's definitely a good thing. Actually, it's very, very interesting. I know Microchip is very proactive in trying to make sure that we're doing as much as we can on sustainability. But sometimes sustainability comes from our customers. We have a number of very large customers, global manufacturer names that people would recognize, that are coming to us and saying, are you complying with all these things? And they're not just the REACH and RoHS standards; they are their own internal standards, saying we want to make sure that you comply up to this level, and they want us to put on our packaging notifications that we are complying up to those levels. So I think in a lot of things, we're almost a little ahead of the curve in stuff. We're not waiting for something always comes up and they'll say, okay, this chemical's not allowed anymore or something. So we have to go back and we have to check all of our units. But a lot of the demand comes actually from our customers, not only from governmental agencies that we have to comply with.
Yeah, that's one of the consistent demands of companies nowadays producing products is you've got regulation pushing you from behind, and then you've got market demand leading you from the front. So it's a delicate balance. The last one here on my list is halogen free. What is the significance of being halogen free?
This was a demand actually from a customer to begin with. I understand, I'm not on the design side, but I understand it did take a little effort for us to become halogen free. And as I understand it, it's now become governmental regulation for it. But again, this was what I was actually thinking of when I was telling you that customers are pushing us to get ahead of the standards.
Does this also apply to our GS series of midspans?
It definitely applies to our GS series of midspans. It especially applies to our GS series of midspans. I think I was mentioning to you that, in looking at what we build, what components go in it, how we build, we've become very, very efficient, and I think we're ahead of the standard. There's always room for improvement. One of the values that we have here is continuous improvement. In looking at this, and we had discussed a company called Patagonia that looks like
That's right.
When something has been completed its life, how do we use it? I think that's the next phase of what we have to start looking at is not disposing necessarily of things that are used, but providing a means to take the stuff that's no longer being used and figure out how to make it useful again. And I think that's
Yeah.
one of the next challenges we have to face.
There was a movement, I think, in the late 90s or maybe even the early 2000s, but it was called Cradle to Cradle. And I think that's a certification that you can get that says everything that you use to make your product will eventually be reused in something else. Nothing goes to grave, nothing goes to landfill.
I do know that when I was moving out of California and I was getting rid of things in my house, including some electronic devices, for electronic devices, I just couldn't throw them in the trash. I
Right.
had to bring them to recycling centers where they attempted, but I don't know what happened after I brought them to those centers. I hope they recycled them.
The bulk of the products, from what I can tell, are textiles and maybe furniture, anything that's made out of wood or fibers. You can usually take those and repurpose those somewhere else. So we might be a ways off with electronic products, but it's good to know that there are certifications out there that set standards for us to reach for.
Yeah, I agree with that. And within that, these standards that are pushing us are also looking at how we can then deliver the energy to the device itself to use. As I said, PoE is the last part of that, but getting the energy to that end device is something we talked about last time using class 4 power,
Mm-hmm.
which is AC is great for long line transmission, but you don't want to have a converter on every single device. And most of the devices in my house nowadays, except for maybe my refrigerator and my washer dryer, are not AC anymore. Are not my washer, dryer, and refrigerator are AC, large motors, but the rest of them are all DC nowadays. And, they all have a power adapter that converts from AC to DC, a big loss of energy between 5
Mm-hmm.
and 20% are some of the estimates that go on there. If we could just convert it once, take the AC to the house, convert it once, and distribute it beyond that 100-meter limit that Ethernet puts on it, and then deliver it that last mile through power over Ethernet, that would be very good. And the standards today have come out. We talked about the National Electric Code coming out with Class 4 power
Mm-hmm.
that now has a new digital type power, digital DC type power to deliver that power so that you can distribute it much more than 100 meters without that high power loss. And I think that's where some of the innovation is coming in today is getting it to the, we figured out how to get it to the home. We're going to convert it once to minimize the power loss. Now we are figuring out how to get it distributed and how to get it to the devices with the most efficiency. And I think that's where a lot of innovation is occurring today.
Yeah, so we get alternating current coming from the power distribution center, which is the power plant in most cases. It's then converted down through transformers like in your neighborhood and eventually makes it to your building. And it's AC at the point of the building. And now there are cases where it does convert from AC to DC, but what you're seeing is mostly it's AC throughout the house and the individual device does the conversion. Did I catch that correctly?
That is correct. And every individual AC to DC conversion, there's a power loss.
Right. That evaporating we talked about. So every time you convert from AC to DC or DC to DC, there's going to be a conversion where energy is lost. And if you remember back from the episode that we did with Kevin Spear back in December of 2023, under Kevin's thesis regarding omnidirectional grids, our power plants make all the power we might ever need in the foreseeable future. But by getting it from the power plant to where we actually use it, those conversions lose so much. So the ability to get it to a point where we might actually save some of it from losing it from conversion or losing it through evaporation, to use an oversimplified analogy, might be really, really efficient in how, one, we generate and manage power, but two, how we pay for power.
Yeah, and I think that that's a very important point because we see devices every day, new devices that are introduced into our lives that are power devices. And these power devices make our lives very, very efficient and make it very convenient for us. But they are increasing the power demand on everything that we have in our on our grids and electric cars. If we go to an all electric car based right now, our power grids can't handle them. So we have to figure out not only a way to generate more power, but we have to make sure that we are much more efficient in the consumption of power. So the incremental amount of generation is not as significant, because I think, one of the biggest challenges is building these power plants. That's not a trivial initiative. If we can conserve some, we can reduce the amount of capacity that we have to put into building these power plants.
So let me go through a list here that I just pulled up, which we can go through, and you can confirm or deny, or you can correct me here. But if we're talking about power over Ethernet devices, this is part of the fascinating part of my conversation that I'm interested in. So at 13 watts, we've got IP cameras, we've got voice over IP phones, we've got wireless access points, and we've got networked audio. At 30 watts, we've got IP telephones, we've got WiMAX access points, and that's for building or citywide Wi-Fi.
Yes.
PTZ cameras. Do you know what PTZ cameras are?
Point, tilt, and zoom. It's cameras that have motors in it. They have sensors in it also, and some of them can react to sound or light, and they will turn on it, or you can remotely access it. The motors will turn the camera so that you can focus on it instead of being a stationary camera.
Remote controlled. Okay, and then we have remote computer terminals. At 60 watts, we have door access systems, as well as video phones and thin clients. Do you know what a thin client is?
Yeah, a thin client is basically, throughout my career, I've seen the pendulum go from a fat client to thin client to fat client to thin client. So PCs came out and everything was a fat client. Then all of a sudden the internet came in and everything would be processed somewhere else, and you would only have a screen to do it on, so that your processing wasn't occurring there. And that screen was the thin client.
Okay. So it's reduction of computing footprint?
Local computer resources, yes.
Got it. Okay, then we get up to 100 watts and we get into digital signage displays. This is your television menu. This is your outdoor display. Point of sale systems, same thing. Your digital menu at McDonald's or your checkout kiosk.
But point of sale kiosks are very much, many of them today are all PoE based.
Okay, and then that allows for power and data transmission, right?
Yeah, and the data is a very interesting thing, and we're talking about devices here that are connected all the time, but also there are a lot of devices that connect to recharge, but they can also download data and information at that. So think of the Fitbit that you wear, or think of the Apple Watch that you wear. When you put that on a charger, you can not only recharge it, but you can also download the data that has been recorded all the day. And if it's health data, it can be reported to your medical providers, and they can keep track of you. So the fact that we can connect and not only do power, but also data, gives us an incredible advantage. And as we mentioned previously, that ability for data, even if the device is not a smart device that requires data, the device can send information to the manufacturer for predictive preventative maintenance.
That's right.
That's
right.
Say
you can get there before it breaks.
That's as you said, the holy grail of where support wants to go. We want to fix it before it breaks.
So rounding out the list at 100 watts, we have LCD TVs, computer monitors, and then at the 200 watt level, we have larger TVs, larger displays, larger monitors, and then eventually laptops.
So power over Ethernet is class 2 power. It only goes up to 100 watts. Actually, the IEEE 802.3 BT standard defines 90 watts. There was a pre-BT standard that went up to 95 watts. Right now, though, people are looking at this and seeing how we can safely deliver beyond 100 watts.
Okay.
So maybe we have two lines going to it. There are a number of things that are being looked at. If we go beyond 100 watts on the existing cable, we would have to put that cable in a conduit, and we would have to change the cable because, as you say, the size of the pipe would not be sufficient enough to deliver that.
Mm-hmm.
That gets to a different class of power. That class of power, according to the National Electric Code, once you go over 100 watts, is not considered safe power, and you would have to put it in a conduit. It has to be installed by an electrician.
Okay, but it's still DC power, right?
It's still DC power.
Wow, it's good to know that there's room to grow.
Well,
As
yeah,
always do.
I was going to say, the way that you presented that was very interesting because 15.4 watts was the first standard of power over Ethernet.
Yeah.
And it was actually used for IP phones, but the IP phones became fancier, so they needed more. So then they went up to 30 watts. And then the last standard that was ratified in 2018 was the BT standard. It added 4 classes. It added 45 watts, 60 watts, 75 watts, and 90 watts to it. And a lot of functionality was added to the BT standard to improve functionality for things such as LED lighting. LED lighting had just begun to become a function of power over Ethernet powered devices. But, the 3 most popular are still IP cameras, IP phones, and wireless access points. But because of the ability to deliver safe power and data and all the benefits of it, we are seeing hundreds of devices today that are now being retrofitted to or redesigned to be power over Ethernet.
Yeah, and at least within this one resource that I found, it seems to have a cadence of doubling. So it goes from 13 watts to 30 to 60 to 100 to 200, which then lends itself to will we get to 400 watts. Now,
Right.
that's beyond the standard of safe, but again, it does lend itself to scalability, I guess is the term.
Yeah, and again, I think this is a place where the power consumption, the power standards are being just like the energy efficiency standards, the power standards are being driven by the people and not necessarily by the governmental agencies.
Mm-hmm.
Prior to 2018, many people were delivering up to 95 watts on what was then considered AT standard. And when the new standard came out, they did not make it the same way that the pre-standard was. As a matter of fact, it's interesting. In Microchip, our PSE ICs have a layer of firmware on it where they can detect whether the request is being made by a pre-standard device or by a standard device. And we can deliver either through the pre-standard set of protocols or through the standard set of protocols. So a lot of this is being pushed by the marketplace itself and not necessarily by the standards organizations. Sometimes the standard organizations are catching up a little bit to what's happening in the marketplace.
But in general, we're looking at the electrification of everything. And so we're going to have to manage that demand.
I believe so. We're up to points where, we have treatments on windows that automatically go up and down because there are sensors to say there is too much light or too much heat in the room or not enough light and not enough heat in the room. And, the window treatments will open or close based upon that. All of that today is actually done through power over Ethernet. The sensors, the motors that do the window treatments, all of that is power over Ethernet. So it's not just, the most common devices anymore. Radios was a very common device for this. Nowadays, you're getting the most arcane devices you can imagine that come in to become power over Ethernet.
The digitization of the mundane, as our chief operating officer would like to say. Alan, as we often do with these, we want to have a place to send somebody if they're interested. So if you have a design or an engineer that is working on a design that could benefit from power over Ethernet, where could we send them?
So the first place I would say to start is go to our Power over Ethernet homepage, which is microchip.com/POE. On there, you will find a lot of, first of all the specifications on the technology we have to offer, but there are evaluation boards that will help them in their design. There are reference designs, and we even have design partners that can help them. Since we have been doing this, we are the pioneers in Power over Ethernet. We have special ESEs or FAEs, engineers, who can look at your design also, and based upon their experience, I can tell you that the two engineers in the United States who do this, one on the East Coast, one on the West Coast, have been with POE ever since it was invented.
Ooh,
so
okay.
They really know their stuff. Same thing in Europe. We have two very good design engineers there too. And we do what's called design reviews. You send us your design. We'll tell you based upon our experience, is this going to work? Is this not going to work?
Great.
And that can all be accessed through the website.
Microchip.com/POE.
Yes.
Great discussion, Alan. I appreciate your time. And I love having these discussions with you because it's the reason we do this podcast is to understand what happens beyond the microchip and that's why it's the name of the podcast, is to see what happens and how it touches our everyday lives. And so if all of these technologies are being evolved using power over Ethernet and DC power, and we can actually manage it, kind of wrestle it to the ground and figure out how to make our lives easier, that's why we do this here. So thank you for your time, and appreciate you coming on the show.
It was great. And I want to close with something that a chief technology officer told me very, very early in my career. He had invented some piece of software, actually, it was at that time. And people were using it in ways that he had never imagined. And he said to me that when people start using your idea in ways that you never imagined, it shows the validity and the benefit of what you have introduced there. And I really do think in what I'm seeing in the marketplace today, with with energy efficiency being so important, this technology that was invented back in 1998 is beginning to become a main center point to helping with that power efficiency objective.
Which is a perfect close because it aligns with our purpose statement. Thanks, Alan.
Thank you.
Alan Zwerin is Senior Product Marketing Manager at Microchip Technology, specializing in power over Ethernet solutions. He joins us today from Tel Aviv, Israel. Thank you for venturing beyond the microchip with us. Join us next time as we continue to explore empowering innovation to enhance the human experience.